virtual thing, internal how it works. Um, and that virtual is the COM component. Mostly some of you will be working with the COM component. So that virtual is mostly used in that COM component. And the design pattern, if you study mostly that virtual is used in also in design pattern actually. So it's very helpful thing actually. So that virtual function, and so it is important for you to know how internally it works actually. So and this virtual actually, the thing which I am going to explore, I have never tried so far. Only like Monday only I was trying. So this is the only thing that I just prepared and I am trying it actually. So rest of the thing is I have been taking out of my knowledge actually. So it's a very nice concept. It means very nice. You will understand the thing. You no need to try that internal working, but it is better for you to understand the things. But before just please concentrate on this virtual what I am teaching. Once if you get that one, then it is very easy for you to understand COM and the design pattern which you will be studying later. Okay. So before getting to that, I am to cover certain other things. So you finished your UA, right? So you showed to send it.
Yes, sir.
What he said?
Okay.
So okay. Then did he tell you to try anything else?
I think we can practice some others.
Okay. So you find easy the dialog controls, right? So initially it will be confusing, lot of parameters. You must know how to use MSDN, all these things. Earlier we get proper MFC help and all, but now it is not getting easier to get those help. Because mostly very rarely they use MFC. It's being used, but
most helping part contains only about wizard.
Yes, exactly. Once if you know the basic design, like from the scratch you know, it is easy to understand, grasp, and you can also go into wizard actually, because wizard mostly they include a lot of additional code which initially when you look into it you can't understand, but once if you do everything from the scratch, then you will understand what they are doing. So that's a good challenge. Whenever you have a challenge, your skill will improve actually. So Sendhil is giving good task actually. Okay. So and Sandhya was trying that operator. So I made some mistakes actually. Well, so what is he was asking some questions right on Monday. Sendhil was asking you about DLLs.
Yes, sir.
What he asked?
Import, export, sir.
Okay, you told him, right?
Yes, sir.
Okay, very nice. So, and one more thing I forgot, like whenever you have a task, right, from the work, it seems like it will affect, not affect. Now, suppose you are studying something like Pawan is studying pointers. Right? Did you try UI thing? What they this? Okay, so you told him.
Arul sir told me to implement maximize and minimize buttons.
Oh, okay, super.
But that implementation not working, but icon is displayed.
Oh, okay. So, what I was saying, I forgot. So what I was saying? Huh? No. Okay, suppose if your team member assign you the task, right? Now what happens is like 2 days back, like 2 days Senthil assigned you a task, but it was little bit dragging your updating knowledge about C++, right? So in that case, what we have to do is like spend some time, 1 or 2 hours in C++, then do your work actually. So you have to balance actually. Sometimes it's difficult, we cannot concentrate both the things together when we have a challenging task. But a challenging task, actually that is where your skill will improve actually. That's better. This is what like you have to come spend time properly actually. Okay. And did you try any UI? What these people try? Okay, so your team member Sri Durga, she is mostly working in some of the UI. I have seen this mail, the Jira mail actually. So mostly they will also assign some UI task. No, they may assign. So just try to get some. So it is very easy, right? So. So last Monday I was saying like you can override or overload operators like these operators. So this scope resolution operator I said, right? So only like after she asked doubt, Sandhya asked doubt. Actually I know, but I forgot actually. So some of the operators you cannot override, only 5 like that actually. So one is scope resolution operator, then what else? Ternary operator. So in Java also ternary is there, right? So then star dot and there are some other things. Which one? No, comma is not operator actually.
Dot star I think.
Dot star you cannot override. So they told you, right? They said the dot star dot or dot star. Dot star. Okay. So and you can override this one actually. You can override this one, and including like she was trying plus plus actually. So in unary operator, right? Plus plus minus minus. So how will you distinguish pre and post? How will the operator? You wanted to write a post increment. What will you do?
First increment and then assign the value.
What is that parameter that you specify? You forgot. Post increment one function, pre increment another function. You don't know. Okay, how do you, okay, unary operator plus plus is there, right? So there is a in this unary operator there are 2 ways you can write it. One is a post increment actually, right, and pre increment. For example, here I will write it. So A equal to plus plus B or A equal to B plus plus. So what this will do, B plus plus B, what will do?
Already increment the value and we can
assign it to A. And what this will do?
It will assign
And then increment. So there are 2 ways of writing this unary operator. You forgot actually. So actually in that book it is there, in that C++ operator chapter. So maybe I will give an example. So this will also take some time, it seems. Okay, I'll give you I'll tell you. I'll just try to remember that int. You pass int in the operator. So that's what it will distinguish between this one and this one. So this one you have, I think, post. What this will do? It will increment and
We can assign.
assign. So it's a pre, right? So in post, this is post. What we'll do is operator plus plus. You will write like this. Okay, as a member function. In this one, operator plus plus. That's it. This is what will distinguish whether you are using this one or using this one. Maybe I will try to cover, if I have time I will try to cover. Okay, so and this one, and also a star also. Very useful thing, these two things actually. Normally you will implement in your code smart pointers. There's something called smart pointers. So it is, when you study about smart pointers, mostly you will be overriding this one, the send and dereferencing the star. So okay, I will not give the example, but you will study actually. So for example, the smart pointer, if you see, maybe I will give the example. Actually, this is not the correct example. I will give the another example. Okay. So what I was so far teaching is the basic understanding of how C++ works internally. And with this you have to just pick up and study all rest of the things. So I will just keep this open. Okay, I will open one more thing. So in order to understand virtual thing, first you need to, I will give some introduction about the function pointers. Already Sandhya also worked, right? So okay. So what we were trying yesterday, Kishore and Ajay.
The same multi-column and then
We are trying the same thing, huh?
Also try this runtime
Operator.
polymorphism operator.
Okay, nice.
other things.
Maybe what So we are following the notations, at least do that. That is very, very important. Whether you change this one or not, you just notation is important. Okay, so for the example of operator overloading, let me tell you. Include string stri string. Okay, so suppose you have a two string maybe is it so string means is actually. So string name1 equal to maybe hello, and string is name2 equal to, so okay, so string is string 3 name 3 equal, okay, so SZ name equal to SZ name plus SZ name 2. So what's the error? Okay. So this is the example. Actually, you concatenate two strings, right? So operator overriding. Either it may be like this. Internally, like a compiler will try to change this one as operator plus as SZ name 1 comma SZ name 2. This one thing, or it will be like this. It will be if it is overloading, like operator overloading, it will be like operator plus you pass two parameters. If it is operator overriding, it will be like SZ name 1 dot b operator plus SZ name 2. So we will be assigning to 3. I am recording, right? Okay. So it can be any one actually. If it is operator overloading, it will be like a simple function with two parameters. If it is overriding, like the object, the first object dot operator plus, and you pass the second one, and it will return name 3. Okay. So this is the one of the best examples. So now you know how to like what internally how it works actually. So using that. Okay, so now keeping this, okay, so I will write one function. So we are just going to see function pointers now. Okay, a function and the function name and the pointers are both same actually. So I'll show you that one. So int maybe some or some add function int I comma int j, and you just return I plus a plus j. Okay. So I'll call this function. I'll just store it in some variable int I equal to 10 comma 20. Okay. Now, if you have a pointer, you can just see those values, right? If you have an address, you can see that in memory, right? So this, I said, it's a function. It has an address actually. So looking at this function in memory, let's see what happens. I'll just copy and put it here. So something is there, right? So what I'll do is maybe it will work or not. I'll just copy this one. I'll go to let me paste it here and just remove the space. Okay, something okay. Something is wrong. Okay. We'll copy till here, I think. Just I am trying to show you what it looks like, that function point. So Okay. Something is wrong, it says. Capstone. Go to assembly. Enter. There was one website that will convert your code into assembly language. So that's what I am trying to search. But it says assembly. Okay. Online assembly. Okay. Enter assembly code and syntax. Okay. Here okay, disassemble. Where is the output? Something went wrong. Okay. Okay, you see, these are all yeah, something you see here, but what we are doing in this function, but it will be even more clear. Actually, I forgot that website. So add some function. What is doing? It's adding two things, right? So you see here, it's adding actually. So that opcode actually, that when you try to display, it shows you it disassemble. These are all like I think it didn't show properly. It's like a stack variable actually, that parameters, and then you add two things, and then it will return actually. Maybe return also should be there. Maybe ARM, begin, So how to convert text to text? I forgot that. Usually I used to do that one. So normally we wanted to see certain functions, what actually they perform. Most of the time we will be working with third-party applications. So we don't know what is their code actually. So and we wanted to hook. Actually, mainly our product is based upon hooking. We wanted to hook certain functions, so we just wanted to see what their function will do actually. So but most of the day we won't do that one, but we just, for our understanding, we just wanted to do. So a function, actually this some function which is an this itself is an address, and if you see this code, it will contain some binary actually. So it is nothing but the assembly operations. So it is for example, roughly I showed you, it contains add, right? It contains that add S1. So even if I remember that another website, it will be more clear actually. So normally we are doing the same thing, right? So a function is just a pointer, but it contains some code to execute actually. So even you can write your own assembly language and then can convert into opcode, and then you can fill it fill as a data and then execute actually. So a lot of low level things are supported in C++ actually, but most of the time Java won't support like this. High level, yeah, that's why. So that's the advantage actually in C++. So, and okay, so now you know, like function actually is a pointer. The name says it's a pointer. So you see this address here, and if you see that it contains all the opcode and operations and all these things. So what next is function pointer. So I just let us not waste time. So just try to understand, right? So I gave a simple thing actually. So finish this one. Okay. So how to declare your own function pointer? So you know, right, Sandhya, how?
Create pointer and assign the function name.
No, that you are describing, but tell me the code actually.
Data type star function.
What is the data type? Yes.
Class name.
No, I am saying function pointer. So what is the data type actually in for a function pointer? There is no data type, right?
Yes, sir. You can use the adding to numbers. You can use int. String means we can use voice and things.
See, actually, you are talking about data types, and this is a function. It's like actually the code actually where your function get executed. There is no data type. In you were trying this.
Function நம்ம வந்து எழுதிட்டு அதுக்கப்புறம் அந்த பாயிண்டர் யூஸ் பண்ணி தான சார் ஆக்சஸ் பண்ணுவோம்.
Yes, correct. We will. How will you declare a function pointer? That's what I am saying. Suppose you are declaring. Okay, let me do one more thing. So we have void star p some void. Okay, and I'm assigning to null. Okay. So p void. Wait, I'm not going to function pointer. So can we do this? No, you can't do it because you don't know the type. You don't know how much to increment because the type is void actually. So void is it means nothing actually. But I'll just say star star. Can we do this? Yes, we can do it because void star is a pointer which is 8 bytes. So when we do p void plus 1 or p void plus plus add 1, how much it will increment?
9.
Yes, exactly, 8 actually, 0 actually it counts. So it will increment 8 bytes actually. So we can do this. So let's see it. So this one is 0 and just incrementing and see how much it is, becomes 8. So it adds it's a pointer to a pointer, it adds one pointer is 8 bytes, right? X8 is x64. So you know, right? So it adds 8 actually, so 8 bytes. Now I'll just say like to declare a pointer you have a type and then the variable name, right? So to declare a function pointer you must know what is the return type and also the parameter. That is what the type actually. So you will use like this type def. Okay, what is the return type for this function? Int.
India.
Return type is int, and you open the bracket, you put star. Okay, and then you can declare a not variable a name actually. You can give the name for type def some pointer, and what is the parameter? Int comma int. This is how we declare a function. So any function which has an int return type and two int taking two parameters, you can use this one. So how to use this? So this is how, this is the like this is same as you are declaring this struct or class class struct name, right? Struct name some struct. So you will declare a variable inside that, maybe int m score n some number like that. So how will you declare this struct? How will you create an object? We create an object like this. So and how will you access it? We just put dot, right? That's it, and equal to some value. This becomes a user-defined data type, right? User-defined data type. Similarly, this also becomes a user-defined data type, but for a function. Okay, how will I do that? I'll just declare one variable. I need to declare one variable. So maybe fn some maybe we'll write like this. Okay, we need to assign it. So what we have to assign? Sorry, code. You need to assign a code actually. So normally this thing is a data, right? You need to assign a code. Either you can write your own code in assembly language, convert it into X, or you just use a function name. This one. For example, fn okay, how will you call this one? Using this one, you can call this one by just passing the parameter. You can also call the same thing like this. 30, 40. So now this becomes a function pointer, which is a, if you see in stack, it is just a pointer which is pointing to one function called sum add function. You can just change any other function which has a return type int and which takes two integer parameters. So it looks very simple, but you will be confused like then where it is used, right? So normally we can directly call the function, right? So why do we do like this? I'll explain you. I'll explain you in virtual actually. I will tell you how we will do that. So first you understand, you just declare a one variable, function variable, and assign some function pointer. Actually you can, this is one thing. I think to write your code, let me add this itself, but I have to convert into hex. I have never tried it. I have to add a comma. Let me try this, it will work or not, but I have seen some example they will normally do like this. So what is too many initializer value? Maybe I don't know actually. I have to search. So something like this we have to initialize. So whether we have to give in quotes or we should just avoid this comma, or I don't know actually. So you can write your own code in assembly language, and like mostly where it is used is like to improve your performance actually. So it will speed up actually. If you have your own, instead of compiler writing for you, you write your own assembly language at some place, it will improve your performance. So but I forgot like how to assign a code to the function pointer. Okay. So but if you Google search, you will get it actually. So and yeah, you can call this as a normal function itself. So for now you just settle yourself like I will explain you where it is used. Okay. Next what I can say, okay, now I just told you about the function, right, and its function pointers. Now so what about the member function? English one. suppose if I have some class, public, you have some int m underscore n number, and you have one function, member function. Maybe it is returning int, maybe some add, okay, and takes int I, okay, and it will return m underscore n plus I. So just a rough function. So how will you declare a function pointer for a member function which has a return type int and a parameter int? How will you do that? How will you declare actually?
Using the same
Huh?
same types.
Tell me the type. Type def int
Pointer some class.
open bracket and pointer,
Some class.
okay, some member mem member function, okay, then I'll close it. Then what is the parameter?
Int.
Remember, Monday I told you one secret actually. When you have a member function, there's one invisible parameter going inside.
Data type.
Exactly,
Data type.
some class.
Yes.
So one invisible function. So I will just tell you again. I made a mistake last time, but let me finish this. So it will be pointer to some class. Oh no, actually. So int, comma int. Okay. Let me finish it. So how will you use that? First, declare a variable some member function fm some function, okay. So fm some member function equal to assign an address of the function I just gave the name. So how will you assign here? Member function. You have a member function here in this class. So you have a member function here. So what will you assign? Some add. But actually it says is undefined. So how will you do that?
Some class dot.
Exactly. That's
Some add.
scope resolution. So some class. Okay, you assigned the address. So what is this?
From mem function, sir.
Which one?
Function, some mem function.
Yeah, function in 58 is the answer.
58. So here will you
Member
declare another
function.
name here.
Member function.
Another name.
Oh, okay. Is it cannot be assigned to an entity of type of, okay, what is some functions is correct, right? Some errors, value of type int so value of type int some class int star, it takes, okay, sorry, actually it's single int, right? So the function has single int, right? So how to use single int? No, it will cannot be assigned to entity. So okay, so I will just typecast it to like this. Will it work? Cast from C declare to okay, std call. Hold on. Invalid type conversion says. Actually, okay, the function. Okay. We do like this. Only non-standard syntax. Use ampersand to create a pointer to a member. Where is saying, maybe here it's saying, we'll see this. Use ampersand to create a pointer to the, okay. Cannot convert from inc declare to, okay, I'll just typecast it to let's see it works. Not typecast to okay, maybe tomorrow I'll tell you like how to do it actually. So member function actually I need to just verify. Okay, you imagine like you have an address and you just assign that address to this member function, to this declaration, right? And then you call the function directly. You create this structure, and then you just pass ampersand s1 comma some 10. That's it. So this will call this function actually. This will call this sum add function. But I don't know how to assign this sum add member function to a pointer to a function. So I will just verify and I'll tell you. Okay, maybe I'll comment it. So, or no. So this is all about a function pointer, and then okay. Suppose you have a function like this. What internally what compiler does is like yesterday I told you, right? Monday I told you, like it will convert into an ordinary function. So how it will convert? Can you tell me? Can you tell me what? How will you convert a member function? Suppose okay, I'll give a clue actually. So you are able to use this, right? This is a pointer. So how is it being used actually? Without your declare, how it's not being declared actually, but you are using it. How it works? Function. Forget about the function pointer. Okay. So I'm just it's a member function, right? So member function. If you like, you are able to use this. And when you convert this member function to a normal function, what you have to do is like you just imagine I'm writing like this. You need to pass some class pointer to this. Okay, this is you cannot use this. It's an defined values. So instead you just for your sake I'll just add this name. So maybe instead of this one I'll so normally your function member function is like this, okay, and you are able to use this. Compiler will convert your member function like this, but normally it won't change, but for your understanding I'm showing this. So your member function will be looking like this. Actually if you see inside your assembly code, your member function will not look like this. You will see one additional parameter is being passed apart from that existing parameter. So normally that additional parameter is that the class actually. So it will create a pointer. So that is why I told you like you are able to use this, because it's hidden inside that this is being used because the parameter it passed internally is this actually, but it is hidden from your side actually. So imagine like this. It will be something like this. Since it is already like you, it's a C++ is reserves this word actually. You cannot use this actually. So just for your namesake, I'll change it to 1. That is why you are able to this one and this one actually. So, but this is hidden from your side actually. But actually there is one parameter that's going on in the beginning of the function, which is the object itself, and that parameter is this. Okay, you understood, right? So that is why when the compiler changes after you build it in your assembly language, if you see your function, some had this function, your code looks like additional parameters being passed actually. So your compiler will change like this. So that is why in type def I gave 2 parameters instead of 1 parameter. You understood, huh? So see, I wanted to declare a function to a pointer to a member function, right? So but in member function it returns int and also takes one int, right? But I gave here two parameters. One is object to that class, and then one int. So normally your function looks internally like this only. So that's why we need to define your any function pointer like this. Member function pointer will be looking like this actually. You understood, right, Sandhya? You have any doubt, or you are not clear? You are clear, right? So why we give this additional parameter? Because internally it takes this one actually, which is hidden from your side, and the variable is called this. That is why you are able to use this here. Okay. So what are the things I made mistake, or which I was not able to do? Tomorrow I will show you again. I'll just browse and I'll try to find out. So now next, what this is the function pointer. Okay, next. So I just covered this operator overriding, and so this correction this is like last time I said we need to pass in reference actually. Actually it's not a reference, it's a pointer. So we need to pass. So that was the mistake I did. Now coming to virtual, first we will see virtual destructor. Okay. You know the purpose of destructor. So how will you declare a destructor? Tilde. Okay. Most of the example code you will see something like that. Maybe I will just add one definition, empty definition. They will also add virtual along with the destructor. Many times you will see something like this, virtual with destructor. But I will not give the explanation. For that I have to teach you inheritance. It is better you give this virtual. So only if I teach you inheritance only that. In Java inheritance is there, right? So but you don't have destructor. Okay, but you have constructor, right? So what is the order of calling the constructor in inheritance, Java inheritance? First is your class object constructor will be called, then the base class constructor will be called, right? In this case, in the case of destructor, if you don't give this virtual, what happens is okay, what I remember is if you don't give this virtual, first base class destructor will be called, and then the object destructor will be called. To avoid that, we need to first one is base. Okay, let me write here. First thing that you need to call is objects constructor. Constructor will be called, and then base constructor will be called. When you normally define your destructor like this, what happens is objects destructor will be called, and then base destructor will be called. But when you give most of the time what we wanted to achieve is we wanted to achieve this one actually. First, the last thing that was called, right, constructor, it should go in reverse order. Earlier it was going in a forward direction. Whether it's constructor or destructor, it was going in a forward direction. But I wanted to go in a reverse direction. Like this was the constructor that was called last. So I wanted to call this base destructor first, and then the objects destructor the last. So for that purpose we give this virtual. Okay, that's one thing. Most of the samples that you come across, you will see virtual destructor. So that's fine. One more thing I forgot actually. So suppose you are allocating an int array of pointers using new. So we are allocating 10. So 10 elements. So what's the mistake? Okay, new int. Okay, new int. How will you destroy this one? Delete, right? Delete. This one, right? We can do this one also. Most of the time your samples or code will be looking like this. This is for the description purpose. Like you are going to delete an array, you can use both this one or this one. But this, if you see the Google help, they will say like just to distinguish whether you are deleting an element. To allocate an element, you will do like this. So one integer value. So n mark n mark. What happened? Okay. So when you are deleting an array, just add include this one. Okay. Variable. Okay, just leave that one. I'll comment this. So most of the time when you see your example code, you will be like square bracket would have been added, but it doesn't make any difference actually. You can also directly delete this one. It will clean up the space. Okay. So now what we saw is function pointers, right? How to declare a function pointer. But I was a little not clear about this member function pointer, right? Okay, no problem. But this will not affect like how I am going to tell you the internals of virtual now. So is there anything else I left? Internal. So now we are going to see the internal working of structure and virtual actually. So maybe I will just save the recording.